Hello everybody, how are you? Today we will solve a lot of questions about integration about trigonometric function. Look at this example, integration about sin x dot cosine x over 1 subtract cosine x dx. First we must put u equal 1 subtract cosine x, and then we can find derivative this function du over dx equal derivative about 1 will be 0, and we can write negative here. Cosine x derivative about this function will be negative sin x. Negative multiply negative equal positive, so du equal sin x dx cross this dx to this function, and we can put here. Okay, what about dx? We can write dx equal du over sin x. This example, integration about this function, let sin x dot cosine x dot dx, we can write du over sin x. Okay, and 1 subtract cosine x, it will be u. We can cancel sin x with sin x, then we can write integration about cosine x over u du. We know cosine x, we can write here cosine x equal 1 subtract u. From this expression we can write cosine x equal, okay, cosine x equal 1 subtract u, and we can write here integration about this function 1 subtract u over u du. So we can find the integration about this function 1 over u subtract u divided by u equal 1 du. We know numerator is derivative about denominator, so this function will be ln absolute value of denominator. Subtract integration about 1 will be u, the last constant, and then we can write u here, u equal 1 subtract cosine x. Then the result will be ln absolute value of 1 subtract cosine x subtract 1 subtract cosine x plus constant. We can write here ln absolute value subtract 1 subtract cosine x subtract 1 plus cosine x plus constant. It's okay. Another example, we want to find integration about this function 1 over x multiplied by 2 plus ln of x dx. We can write u equal ln x. This example, let u equal ln x, okay, ln x, and we can find derivative about u du over dx equal ln x. We can write x here, and derivative about x equal 1, and we can write the result du multiply x equal dx. Okay, then the x equal x du, and in this example we can put here integration about 1 over x equal, we can write x here, okay, write x here, and 2 plus u ln x, we put it here ln x equal u, and dx equal what, x du dot x du. Can cancel x with x here, then the result will be integration about 1 over 2 plus u du. we can find the result about integration. We know 1 over 2 plus u. 1 over 2, we can write it outside here, and we can add ln here because numerator is derivative about denominator. The numerator was derivative goes to denominator, so we can write ln absolute value 2 plus u plus constant. Again, we know the numerator 1. 1 is integration about u. The integration about u will be 1. So numerator will be derivative about denominator. So we must write ln absolute value the denominator, and we can write plus constant. And then we must write u equal ln x here. Then the result will be ln absolute value 2 plus ln x plus constant. We can write u equal ln x. So the result will be ln absolute value 2 plus ln x plus constant. Another example, we want to find integration about this function 1 over 1 subtract e power x dx. We can let e power x equal what? Equal u. We can write here e power x equal u, but we can simplify it by multiply e power x to numerator and denominator to find the result. But we can find the result by write coefficient about denominator. We can write here 1 over e power x outside outside here. Its coefficient about two term. 1 divided by e over x, it will be e power negative x. Subtract e power x divided e power x equal 1. Okay, it will be dx. And we can write e power x from denominator to numerator here. The result will be e power negative x over e power negative x subtract 1 dx. It's okay. And we must put u equal this expression. Let u equal e power negative x subtract 1, and find derivative about this expression du over dx equal e power negative x. We can write what? E power negative x, and derivative about this power will be negative. Okay, and then we can write dx equal we can repeat it all to term here. We know the product about extremes equals the product of means, so dx equal, we can write dx here and negative e power negative x here. Okay, so dx here replaced this two term here, dx equal du over negative e power negative x. Okay, and this example we can write here. Look at this example, we can write e power negative x equal u plus 1. In this example we can move this term here, so e power negative x equal what? Equal 1 subtract u. Look at here, we can write e power negative x equal 1 subtract u here, 1 subtract u over this expression. We write it here u, and write dx equal du over negative e power negative x. It's okay, and we know negative e power negative x, we can cancel it by u. We know it will be 1 subtract u. We can write it here negative e power negative x equal what? Equal, again we can write it here e power negative x. This example we can write e power negative x equal what? Equal u plus 1. e power negative x equal 1 plus u. And this example we can move it here, so negative this expression negative e power negative x we can write here by left hand side, and 1 subtract u equal 1 subtract u. So we can write e power negative x, e power negative x here, e power will be 1 plus u, 1 plus u. Okay, we must know the sign about this expression, and we can find it's the result negative e power negative x right here u over this expression. What's about expression? We can write negative here, 1 plus u, right? Negative coefficient outside here. About this expression, we want to find negative e power negative x, right? Negative outside, and we know e power negative x equal 1 plus u, 1 plus u here, and write negative outside. Okay, why we do it this step? We can do this step to cancel this expression with this expression, and the result will be 1 over u, and write negative outside du. We know numerator. What about numerator derivative? About denominator, so we can write negative here, ln absolute value to the denominator plus constant, and we can cancel u here and write e power negative x subtract 1. Then the result will be negative ln absolute value u was e power negative x minus 1 plus constant. It's the result about integration of this function. Okay, another example, integration about 1 over root x multiply by root x plus 1 dx. In this example we can put u equals this expression, let u equal root x plus 1. So derivative about u by x equal, we know the derivative about 1 about root x equal 1 over 2 root x, and derivative plus over 1 about 1 equals 0. Then we can write here, we can replace du multiply 2 root x equal 1 times dx. It's okay. Okay, and this example we can write here root x will be equal u subtract 1. Then we can write here 1 over u subtract 1 multiply by u, and dx equal du multiply 2x root x, 2 multiply root x du, and we can cancel this expression root x with u minus 1, because root x equal u minus 1, this term equals this expression. Okay, and the result will be 1 times 2 equal 2 over u du, and we know 2 is a constant about this function. We can write it outside here, 2 integration about 1 over u du, and integration about numerator and denominator. We know 1 is the derivative about denominator, so we can write 1 multiply ln absolute value to denominator plus constant, and u we can write it root x plus 1 equal to ln absolute value about root x plus 1 plus constant. Look at another example, integration about this function cosine ln x over x dx. Can you solve this example? We must put u equal ln x. Okay, let u equal ln x, and derivative about u du over dx equal ln x, derivative about it 1 over x. Okay, so we can write du equal 1 over x dx, and we know dx equal what? Equal x times du. and we can write dx times 1 equal dx, x times du, x equal x du, because the product of extremes equals the product of means. So in this example we can write this example: cosine u over x dot dx equal x du, x du, can cancel x with x, integration will be cosine u du. We can write integration about cosine u du, it will be what? It will be sine u. We can write sine u, because integration about cosine will be sine, equal sine u plus constant, and we can write sine here, and u was ln x, sine ln x plus constant.